Okay, so for this session, we're going to be graphing a residual plot and creating a line of best fit using both Desmos online graphing calculator and a Ti-83 virtual calculator that's been downloaded onto the desktop computer. The problem we have is about the braking distance that's required based on the speed of a car in miles per hour. We are given a table of values where x is the speed in miles per hour and the y value is the braking distance in feet required to bring the car to a full and complete stop. We're going to use Desmos first. You can go ahead and visit desmos.com/calculator and then click on the plus sign top left hand corner. Then you will select table and you'll see that you've been provided with an x1, y sub 1 table of values in which we'll go ahead and enter all the data that we have from the problem. Once you're done entering the data, you can go ahead and click on the add sign, add item one more time. And then now we're going to ask Desmos to give us an expression that represents the line of best fit for the scatter plot we just entered. Go ahead and click on f of x expression. And then we're going to type y1 tilde, this little squiggly sign on the keyboard, mx1 plus b. Now, as you can see, we don't have a good visual of the scatter plot. In order to go ahead and be able to see the scatter plot clearly, we can click on the plus sign magnifying glass, the zoom fit feature at the bottom left of the table. That will go ahead and readjust your screen to where the scatter plot is at. Over here, we can tell that we now have a value for our slope m of 5.42857 and a y-intercept of negative 133.905. This is how you would use the Desmos online graphing calculator to create a residual plot and get a linear regression model. Now we're going to go ahead and do the same thing using a Ti-83 that I have again downloaded a virtual emulator of onto my computer desktop. First, we'll go ahead and clear everything. This would be the normal menu for your Ti-83 and the visual of the screen. Again, we're inputting a table of data and we're going to get a linear regression model for the data. Let's go ahead and first begin by clicking on the Stat button. And then the first menu is the Edit menu with the first option at 1 to edit. We'll go ahead and select 1 or use 1 button on your keyboard to get into the menu. For L1, L2, these would be our x, y values. So first, we'll go ahead and input all of our x values and then scroll over to the right and start inputting all the corresponding y values from the table. Once we've completed the table of x, y values, we'll go back to the Stat button one more time and then scroll to the right to the Calc menu. Then you can either scroll down to number 8 or you can just select number 8. It's for the linear regression. This will show up on the main screen of the calculator. And now we're going to go ahead and ask the Ti-83 Plus to derive the data from the L1, L2 menu we had created earlier. To get into that menu, you'll need to go ahead and click the second button and then number 1, which is L1. Go ahead and enter a comma Select second again, L2, and then hit enter. As you can see, the Ti-83 derived the A and the B value for us, which would be the slope and the y-intercept of the linear regression model for the line of best fit. If you compare these values to Desmos, hopefully you'll be able to notice that they're exactly the same values. Both graphing calculators, whether it's Desmos or your virtual Ti-83, should give you the same exact values if you entered the data correctly and exactly the same on both platforms. Hopefully you've enjoyed watching this video and you are now able to use either Desmos or your Ti-83, which are both virtual tools to create lines of best fit for a linear regression model.